Hello everyone, welcome to Young Innovators. Hope you have watched the previous session in which we spoke about transistors, its working and type. We also built simple circuits on Tinkercad using transistors. In this video, we will be looking into some more circuits on transistors. In our earlier sessions, we have learnt about resistors and its working. In this video, we will look into another type of resistor called an light-dependent resistor.
A light-dependent resistor is a resistor where the resistance varies based on the amount of light falling on it. The resistance offered is less when the light is more, and the resistance offered is more when the light is less. When the LDR is kept in light, the resistance will be in kilo ohms, and when the LDR is kept in dark, the resistance will be 1000 times more than that when it is kept in light. LDRs are also called as photoresistors or photoconductors. They work on the same principle like that of a photoconductivity. LDRs are used in street light due to its property of changing the resistance value at different conditions, which helps in switching the lights on and off during day and night respectively.
Before we dive into the session, it's important that you have watched the earlier session on transistors and its working. In this session, we shall learn about the purpose of LDR in a given electrical circuit. Having this knowledge on LDR, we will use the component with transistors and see the output variation and working of the same. Let's go to Tinkercad workspace. We shall build a circuit to control the speed of the motor.
Let us look at the circuit diagram. The components that we need are a battery, a PNP transistor, an NPN transistor, a hobby motor. We have 3 or 4 motors on Tinkercad. We will take a DC motor here. We need 2 resistors of 470 ohm and 10 kilo ohm, and a photoresistor or an LDR. We can build the circuit directly or on a breadboard. As there are many connections to be made, we will take a breadboard and start building the circuit. So here I have all the components needed. We will connect the battery to the power leads on the breadboard. Now from the negative terminal of the battery, let me connect it to the emitter of the NPN transistor, and the base of the NPN transistor will go to the 470 ohm resistor. The other end of the resistor will be connected to the collector terminal of the PNP transistor. The collector terminal of the NPN transistor will go to the negative end of the motor, and the positive end of the motor or the terminal 2 of the motor will go to the positive end of the battery. The base and the emitter of the PNP transistor will be connected through a 10 kilo ohm resistor. One end of the 10 kilo ohm resistor, that is the base and the 10 kilo ohm resistor, will also be connected to the LDR, and the other end of the LDR will go to the negative end of the battery. The other end of the 10 kilo ohm resistor where we have connected the emitter will go to the positive end of the battery. This completes the circuit. And on clicking start simulation and pressing the LDR, we get a slider, and when the slider is at the dark position, the motor will not spin, and on moving the slider at the LDR, the motor starts spinning, and when the LDR is completely at the right position, the motor spins but with a less RPM when compared to the RPM or when compared to the speed of the motor when the slider is in between dark and the light value. So this explains how we can control the speed of the motor or how we can vary the speed of the motor by sliding the knob or sliding the LDR from the dark end to the light end. That is, when the LDR is kept in dark, the motor will not spin, and when the LDR is kept completely in light, the motor spins. In other words, we can say that the speed of the motor or the working of the motor is completely dependent on the amount of light or the intensity of light that falls on the LDR.
Next, let us look at a similar circuit where the output is seen only when the LDR works. The next circuit is the circuit of a darkness activated lamp. The darkness activated lamp is the lamp which glows when the LDR is not receiving the light. This is the circuit diagram. Make a note of it and try it on your own. The components needed are a breadboard, a 5-volt battery, a slide switch, a PNP transistor and an NPN transistor, a lamp, an LDR, and a resistor of 100 kilo ohm. We have all the components on the workspace. Now let us connect them as per the circuit diagram seen on the right corner of the screen. Let us connect the battery to the power leads of the breadboard first. Now the negative terminal of the battery will be connected to the terminal 1 of the slide switch. From the common terminal of the slide switch, we will connect it to the bulb . From the other end of the bulb, let's connect it to the collector of PNP transistor. From the base of PNP transistor, we will connect it to the collector of the NPN transistor. And the emitter of PNP transistor will go to the positive end of the battery. The emitter terminal can either be connected to the bulb or to the common terminal in the switch. The base of the NPN transistor is connected to 2 points. One is the LDR and one more 100 kilo ohm resistor. From the other end of the LDR, connect it back to the common terminal of slide switch and from the resistor other end, give it back to the positive terminal of the battery. This completes the circuit. Now, let's start the simulation. The bulb will glow only if the switch is on and the LDR is covered, and even if the switch is on, and if we uncover the LDR, the lamp or the bulb will not glow. This tells us that the circuit works only if the LDR is in dim state and not in bright state. So, this was a simple circuit on how LDR can be used to vary the intensity in a circuit. You must have seen the street lights turn on and off during the night and day accordingly. Do you think solar panels or solar cells work similarly as that of an LDR? Hope you guys enjoyed the session. Thank you for watching.